Hi everyone, in today's video, we're gonna look at LangChain Expression Language. This is like one of the feature that LangChain has recently released, and they have been using this particular syntax or the expression language across their new features or whatever the things they are doing recently. So if you remember, we have recently look at the LangChain templates is another feature that they have released, which is nothing but you can build a production ready LLM application using some of the LangChain templates what they offer. So you can think of templates are nothing but some kind of reference architecture, and you will find all different use cases they have covered, and you can take this particular template and start building your application by customizing this template. So I have covered the video LangChain template that you can go and watch. So when we look at that video, we saw the LangChain templates also heavily using this something called LangChain Expression Language, right? Which is nothing but it's a declarative way using which you can easily compose or combine LangChain components like your prompt, language model, your output parser, and compose them as a chain together, right? So this is like an easy way to doing things. And so what we're going to look at in this particular tutorial, we're going to see what is exactly this LangChain expression language. We're going to look at some example, and then we will see why we should use it, what are the advantages of it, and finally we will see a RAG example, which is nothing but the retrieval augmented generation example with this LCEL, which is LangChain expression language syntax. So let's first of all go into detail and see what exactly the LangChain expression language. So rather than actually talking more, better we see the example so that things are clear what exactly this expression language. So let me show you first of all what we have here. So first thing, we require the LangChain, then we require OpenAI because we're gonna use OpenAI LLM, and also I'm gonna use OpenAI embedding for the RAG example. So we require this particular library for the RAG, these two things. So let me install them. And since we're gonna use the OpenAI LLM, I need to set my OpenAI key here. So I'm setting that key as a environment variable so that it get accessible throughout our program. Okay, I think it's installing. Okay, so I think it has installed, and we already set the environment variable here. Then what things we require from the LangChain? So first thing we require a LLM. So we're gonna use the chat models like a chat OpenAI. So chat model is nothing but something which can take our chat history or the list of messages and produce one of the messages output like a chat GPT, GPT-4, that kind of stuff, right? Then we also gonna import the chat prompt template, and then we can take any output parser. So currently we gonna use since we know that the chat OpenAI, or let's say any OpenAI chat model, gonna produce output as a chat message, or the and then we can convert that message into the normal string. That's why we can use this particular output parser. Now let's declare. So we're gonna let's gonna create the chat OpenAI, which is like by default it should be 3.5 model. Then we're gonna create the instance of the output parser, and then we're gonna create the instance of the prompt. Let's look at what exactly we have for the prompt. So we are saying we're gonna provide some product notes, and we want to generate the description for that particular product. Now this is our typical LangChain, nothing new. If you have seen a LangChain video, then any LangChain video, these are the couple of things we know, right? So what exactly the LangChain guys implemented? So we know these things we can call as a component, different component, like model is one of the component, the output parser is one of the component, the prompt is also one of the component. Now what they did actually, they make sure each of these component have a standard interface, and each of them implemented this particular interface. And that interface called the it implements something called the runnable protocol. It means each of this component what you saw gonna have some couple of method or the interface, that's gonna make it easy for us to combine them together. And let's look at what exactly those methods. So one of the method is called invoke, nothing but we can pass input to that particular component. The other method is called the batch method. The batch method is nothing but instead of one single input, we're gonna pass the list of inputs, And the another thing is the streaming. We want to get response as a stream of characters. So let's say we want to get the streaming response, right? So we're going to look at all of these things. So this particular interface they implemented for each of the component this, and that made them actually possible to combine them using this LangChain expression language. So let's look at what I mean by each of them has this particular method. Now let's look at our prompt template. We know the template is also one of the component in the LangChain. So let's see if I want to call the invoke method on this particular template, because we know it supports that particular method, right? So invoke is nothing but we are calling that component. So we are calling the prompt and we are passing input to it as a key value pair. We are passing that product nodes is equal to this. And we know that eventually this prompt will get formatted and we should see the complete prompt. I think we need to run the upper cell also. Okay, and let's run this thing. Now if you see, when I call the invoke method on that single component prompt, I am able to get something called the prompt value or the chat prompt value, and you can see that is nothing but actually the list of messages, which is nothing but the typical or chat GPT prompt, which is the list of messages, and there is only one single message, which is the human message, right? And you can see it has our instruction for our prompt, and it also has the input that we provided, which is the product nodes. So this is how you can actually let's say format your prompt. Now from this prompt we can actually get this whole prompt as a normal string also. So we can call the prompt value we can call the toString method, and we should be able to get the string representation. So you can see string representation, that human instruction is this, create this engaging product description for this particular, based on these nodes that what we have provided, right? And we can actually extract that a typical chat messages that we can pass to the model. So we can call two messages function and we will get the, you can say we got it as a list of messages or the message array we can call it. Now let's look at the second component, which is our model. Okay, and let's invoke that component. So we can similarly, we can take our model and we can call the invoke method, but model requires, because we know it is a chat model, the input should be the list of chat messages or list of those, whatever the messages we have. So we're gonna pass the same thing here as the input to the model, and we should get the output as one of the message, because we know that the chat models takes list of messages and produce a message object, which is actually the AI message object. So at the moment we are actually calling LLM, and we can see we got some description here, and the description, the output is the AI message. So this is how we saw that we are also able to invoke a second component, which is our model. Let's do the same thing. We can, since all of them are implementing this interface, we should be able to call the invoke method on our output parser. So let's take the output parser and call the invoke method, but this time we will provide our model message to it, whatever the model output we got, which is actually the AI message, and we should get our normal string because it is actually the string parser. And we could see instead of that AI message we just got the same thing but as a string variable here, or not, sorry, variable, as a string what we got this particular output. So these are all nothing but the components that we saw. We can execute the prompt, we can execute the model, then we can execute this parser independently. But using the LangChain expression language, we can make this whole execution very clean and very easy way we can compose the chain. Let's say I want to execute now the same thing using the this expression language. So I can create the chain like this, just like this. So this chain represent that I want to chain these different components together. This is what we are calling, we are composing those components. So we are saying I want to create the chain, which is nothing but the sequence of components. First thing is the prompt, then whatever the output of the prompt should go to the model, and whatever the output of the model should go to the final output parser. And then actually you can have multiple such a components here, right? You can again might have one model and then to do the parsing and all of these things. And just like each of these components we executed using the invoke method, even the chain support that same method. Now let's do the one thing. Instead of calling them each of them individually and then passing each of their output to other component, we can simply say chain.invoke and our input will go through this chain, right? Let's do that thing. So let's declare this chain here. Let's look at the chain. If you print the chain object, what we see? Okay, so you can see we got this chain is nothing but the first thing we got the chat prompt template. That is the first thing in this particular chain, this one, which is our prompt. Second thing, we see the OpenAI model. With OpenAI key, you can see the key attached to it, which we set through the environment variable. And the final thing is the string output parser. Nothing but it is the same thing. Only it is we can see the actual object that what we have passed. Now let's invoke that string with the same message that we starting invoke our prompt, and let's see whether we get the similar thing as a plain description. This is what, right? So we got the description. You see, this is how it is easy. You can easily compose those different components together and compose a bigger chain or a more complex chain with this easy syntax, because the LangChain internally, this expression language internally handles passing this output to this particular thing, making sure they are compatible, all of those things. And that is one of the reason we should use actually, you can see how cleaner this particular compared to what I was doing independently, right? And so that is one of the reason that it makes you easily compose this thing, right? If you go here, the why we should use the LangChain expression language, there are many reasons. So definitely one of the reason is the invoke method, and we saw with, if I want to implement this invoke method myself, I need to call the OpenAI model, I need to format that output, but then we could do that thing very easily with this LangChain new syntax. Another thing is actually streaming support, right? So it has inherent inbuilt, I would say, the streaming support, so you don't need to write much. So you can simply iterate through the output and you will get the stream of output rather than writing the OpenAI streaming code and all of those things, right? So let's look at that example. That same chain what we executed, we can actually execute it as a so let's see what happens when you execute this thing, right? When I executing this particular thing, whole description is generated, and then OpenAI sends me that description, and at once I show that description. So there is no streaming happening. But here what we will do, instead of calling chain.invoke, we will call the chain.stream on a same input. But here it will start, as OpenAI model start generating those characters here, we will receive them as a stream. So you could see we are continually we are saying something we are receiving, right? Rather than without writing much code, we got the streaming support, just nothing. We simply got the stream method and we got the streaming support. So that's another reason why we should use actually the LangChain expression language, right? One more interesting reason which I like is actually the batch, right? We know that most of the time we need to pass not just the single input, but actually the list of inputs to the LLM, right? Now, if I want to do myself the batching, or let's say one way, I can simply pass one by one. First, I can run for this, then second for this, but then what will happen if, let's say, one description generation is taking 7 seconds, the 10 description will take us 70 seconds, right? But I know when I'm generating for this description, there is no impact or dependency on this particular description, right? So I can run them parallelly or write to it parallelly, right? So if I want to run them parallelly, what I will do, I might write code using called thread pool executor, have a multiple thread and workers run, right? But using this syntax or the new expression language, I can simply call the chain.batch and it will do that parallel thing for me. And we can see now, let's say I have these 10 inputs, and then I can call the batch, and we will see whether we know that for a one particular thing it took 7 seconds, and now we have the 10 examples. If I run sequentially, it will be on average 70 seconds, 70. Now let's see how much time we saved by just calling chain.batch instead of calling them iteratively. Okay, let's see. So it took a 28 seconds actually to call this particular thing. I was expecting a bit less, but that's still pretty good. Instead of 70 seconds, it took like, let's say, 25, 28 seconds. What if I run again? Because sometimes you see some delay because of the some load at OpenAI. So actually we should use that time it functionality, where you could run multiple time and then take average and all of those, rather than relying on this sale timing. Okay, it took only 16 seconds this time. This is really good, right? So you can see that the 10 example without I writing any parallelism code, it just handle because it supports the batching of thing. And this couple of these things is definitely, making us that we should use the LangChain, expression language. So let's look at the more kind of a concrete example, because we know that most of the time we are using LangChain in the context of RAG, which is, retrieval augmented, generation, where we just don't pass something. Actually, we need to retrieve some context information from the document, right? So what I did to keep it simple, I just created this fictional document using ChatGPT. So we got a list of documents here. Each string or each element in this list as a big document. Let's call it a document, okay? And so what we want to actually get answer based on this particular documents what we have. So let's run this docs. And now since we're going to use the RAG and we will be using OpenAI embedding, this we don't need to import because I think we have already imported on the top. And we're going to require the chroma vector db. So let's run this thing to import the thing. Now let's create our vector store or vector database, chroma vector database. So chroma has a method here. Vector store has a method called prompt text. So we can provide the list of text or the list of string, which is the docs, and we can also specify what embedding we want to use. So we want to use the OpenAI embedding. This way we declare our vector store, and then we can use this store itself, vector store, as a retriever. So we can use it as a retriever so that we can pass something and we will get the relevant documents written. We can add some extra arguments saying that, okay, hey, I just want to get top k is equal to 1. So let's say we have this couple of documents and I want to ask how social media data used to influence the political opinion. And let's say, again, interesting thing. I told you each of them has a method called .invoke, right? So I can even take this retriever and only call invoke method to see how this component is working. So let's run this thing and let's see. Okay, we can see which document it got matched. So it got matched with document called social media and politics. It says that the Cambridge Analytica scandal, because the document is about that only, the Cambridge Analytica scandal, right? So we could see that at least our retriever is working good. When I ask about something social media and political influence, it selected the appropriate document, and I only give k is equal to 1, so I just got one document in return. It means now I can use this retriever as a one of the component in our chain, a LangChain chain, right? So let's, now we need a different template, because the other template was something product description generation. We need a very simple typical RAG template where we say that, hey, answer the question based on the following context. This context is nothing but this document, what we got from the vector database. And then this is the question which is coming from the user, which is nothing but this, right? So we declare our chat template which has this particular format. Again, we're gonna use some OpenAI model. We require the output parser, and then what we're gonna do, we're gonna actually, let's say we're gonna create the chain. But before, so let's say we know that we're gonna require the prompt. We need to pass that prompt to the model, and we got the output parser. But before we construct the prompt, we need to actually retrieve the context from the retriever. So the first step is actually getting values for the context and getting values for the question. And this is nothing but what we have defined here separately. Call the first step we call as a component, or the step we call as a setup and retrieval. So we are using something called runnable parallel. So we know that these are all components. And runnable parallel, what it does, whatever the values you want, here I want context, here I want a question, it can actually execute them parallelly. Now here it doesn't make any sense, but let's say instead of this, I had something called the context 1, right? And then I have context 2, one more to context 2, right? And then this is the retriever 2 and the retriever 1. What if I have, and imagine my context is actually the concatenation of retriever 1 context and the retriever 2 context. Now in this case, how runnable parallel would have helped? It would have calculated the context 1 and context 2 parallelly, because it knows to get the context one, there is no dependency on the context two. So this way, if you have a multiple retriever or the multiple steps actually which can be run parallelly, you can put them inside the runnable parallel and it will execute them parallelly. At the moment here we are only doing this question and this context, right? And I will show you we can do this without actually the syntax. Okay, so but for now the first step in our chain is actually getting value for retriever and the getting passing through the question. So in the line chain we have runnable pass through when you want to pass user input through your chain. So that will be pass through this particular model. So whatever we're gonna pass here, it will assign that value to the question. Now let's run this thing because we it's the same thing which is gonna run what we tried with the retriever. Now we directly pass that same thing with the chain, and now we should see we got the similar answer, right? Means here we only got the document in the return, but now here what happened actually, this output of this document, this went inside the prompt, then we got the formatted prompt, and eventually that prompt went to the model and we got the output parser. So same things happen, but now we could see that we could get those values. Now here you might say this complicated, so I can actually let's comment this thing, because the first step is what we require. We only want these two values, so I can directly put this also, that hey, the first step is actually I want context which is going to come from retriever. The second thing I want question which is going to come from the runnable pass through, which is nothing but the user input what is going to be there, and I should be able to still get the same result. Okay, I got the same result. I told you that this is like, but you could make this parallel execution, so there is a special thing, right? And it would make sense. Imagine you have one retriever related to some other document, there is another retriever, maybe database related retriever, right? So if you have multiple retriever, you can run bring the context simultaneously using this. So this is what runnable does, right? So this is all about LangChain expression language. So we look at what exactly is it by looking at some simple example. Then we talk about why should we use it. The popular reasons are definitely the syntax, the way it makes it easy to compose the actually the chain. Then the invoke method that it supports, which makes your code very clean, and you reduce lot of boilerplate code. Then we saw that it has inherent batch support with the parallelism inside and then streaming, right? One more thing, it also support the async, right? So instead of calling invoke, you can simply call a invoke and it can be used as a async, so where you don't want the blocking call, you just need a non-blocking call, right? So you can even use as an asynchronous way. A lot of many things I have provided the link to the different things that there is many things that we could actually explore, so you can go and check. So it has a support for the logging. I think you can easily log all this information in the Langsmith, which is another feature. There are a lot of fallback and thing also it provides, right? So I have just covered the basic things to something that we can start using in our real examples with the real projects, and then eventually build more complex solutions, right? So I hope you found this video useful. I'm going to attach this notebook link inside the the YouTube video description. Thank you.